Hey everyone, I want to make a quick review video for what you're going to see on the quiz for getting a position time graph and needing to create a velocity time graph, an acceleration time graph, and then the motion map that goes with that motion. So this example here is the position time graph from one of the ones in your workbook. And when we look at position and time, what that tells us is where the object's going to start. So I know for my motion map, I'm going to be starting at the origin, and as time goes on, I'm going to end up far away from the origin. I'm going to move from left to right on my number line when I get to my motion map time. What I want to look at is how does my object move at different times. So what I like to do is I like to focus on at least 3 locations. I focus on the beginning, I focus where this break is, and then I focus on the end. And at each of those times, I know that position over time, meters divided by seconds, tells me velocity. So the slope of those 3 points will actually give me my velocity graph. If I put my pencil along that first point, you can see my slope is completely flat. There is no slope. So my first velocity must be 0. My second velocity is positive because my slope is now pointing in the positive direction. And my last slope is positive as well. And the nice thing about those 2 slopes is that this slope and this slope are identical. They are both positive and neither is steeper than the other graph. So I'm going to take those 3 things, the 0 slope, the positive slope, and then the other positive slope, and make my velocity graph. So we said that for the velocity graph, the first slope was 0. So I'll put a point at 0. The second slope was positive. So I'll put a point at positive. And the third point had also a positive slope, which had the same value as point number 2. What I now do is I connect those 3 dots. I connect starting velocity to the second velocity to the third velocity. And what you end up seeing is that your velocity is going to increase until you get to that break, and then my velocity goes constant. I move at a nice constant velocity for the rest of the time. To make the acceleration graph, we do slopes again, but now we do slopes of the velocity time graph. So if I look at the slopes again for my first segment, this slope is positive. My first acceleration must be positive. My second slope is flat, and a flat line gives you 0 acceleration. We're not accelerating, we go at steady speed. So let's make the acceleration graph. So on the acceleration graph, I knew my first slope had to be positive, so I will draw a positive acceleration. Positive acceleration that is constant the whole time. For these sections, our accelerations will be flat lines either in the positive region, the negative region, or the 0 region. For the acceleration, after when I start moving at steady speed, I no longer accelerate, so my graph drops to 0. So I have positive acceleration during the first segment and 0 acceleration during the next segment. So now what we want to do, now that we've made the velocity and acceleration graphs, we want to make our motion map. And our motion map should correspond to what the velocity and acceleration graphs tell us. So remembering that the object started at the origin, I'm going to put my first dot at the origin. The object started out slowly, so it's not going to get very far in that first moment, but it's going to get faster and faster as time goes on. So those dots are going to get further and further apart. But eventually, I'll be going to steady speed, so now my dots will match up to having equal distance at that moment. What I can do now is connect these motions and say that I had a velocity that was slow in the beginning, and my velocity got faster and faster as time goes on, but then I hit that moment when I go at a steady speed. So I can see my velocities are increasing here from 1 to 2 to 3, or when I get to that break in the graph, I now know my velocity is going steady every single second. So now we need a corresponding acceleration. The acceleration always, we said, points towards the bigger arrow if you are accelerating. So in that first segment here, for these first 3 arrows, I am accelerating, and I'm accelerating to the right. The right is the positive direction. So I'm going to draw my acceleration underneath that, and my acceleration is positive and constant. So I have a constant acceleration to the right because my velocities are increasing to the right. But then I get to that segment where my velocities are nice and steady. With my velocities being nice and steady now, we said I was no longer accelerating. And if I'm no longer accelerating, all those arrows for this segment here are the same length. I'm now going the same velocity each second. So since no arrow is bigger, I don't need to draw an acceleration vector. But what I do need to do is include the acceleration dot. And for this segment, I am no longer accelerating. So this says acceleration equals 0, and this says acceleration is positive. I hope this quick review helps you go through the rest of the practice problems in worksheet 2 and 3, and good luck on your quiz.